Oh, my GIF turned off. Let's start it up again. Hi. How many people here play chess? Okay, awesome. So this, yeah. Yeah, exactly. I love chess. Chess is awesome. It's like a good game to keep your brain active and engaged. It's a good way to compete in a kind of well-known puzzle. And I play a lot of chess with my brother-in-law, Todd. He kind of sucks. I beat him every time. But it's how I spend a lot of my downtime. Has anyone played chess with friends, like on their phone? Okay, a few of you. And it really started to annoy me. Like, I play chess. Maybe I capture his queen, or maybe I have a setup that I know is going to turn into a win, and I make the move. I know that he's looking at his phone right then, and I know that he's already made his move in response because it's pointless, right? And it just takes so long for that move to actually make it back to my phone, right? Sometimes we'll even have a pretty engaging game, and we'll be sitting next to each other, and it still takes maybe a minute even for that move to process. And I started to be like, you know what? Chess is an exciting game, right? Oh, here, thank you, David. You brought me some coffee. Chess is an exciting game. Chess is as much about the move that you make as the spaces in between the moves, right? Like, if they respond quickly, then they're kind of making a statement, whether it's intentional or a tell or a bluff as to what their confidence is. And you can see just even in the pacing of this, I think this is some like early 90s chess tournament, that it's exciting. Chess should be fun. It should be exciting. It shouldn't be kind of like sending a letter or sending a slow message across the country. So I was frustrated with this chess with friends game, and I'm like, you know what? I should make my own. How would I make something that has the same energy and excitement as the chess halls, that you see here, or if anyone's been to like Washington Square Park and have seen like these guys that are smack talking each other and competing in the greatest game. And I started looking into it, and this talk is really the story of how I built the chess game, just because I was interested in how to do it. We touch on Socketio, which is the technology that I used to build it. And how many of you are Node developers or done some Node development? Okay, a good chunk of you. And how many people have done some Socketio? Okay, good. That's like a good balance. I've kind of structured this talk as more of an introductory talk, and this is the introductory room, so that's good. We'll be starting from scratch, building the chess game. But the main part of the talk is on the Socketio piece. So if you haven't done Socketio and you want to kind of grok the concepts and really a real scenario where it's actually helpful to use it, sometimes you like do a technology talk and you kind of see what the pieces are, but you're like, why would I do that? Or how would I do a real thing with that? The point of this talk is that you kind of, at the end of this, you'll kind of know how to do something like this in a relatively straightforward way. And then you can just swap chess out for like your project of choice. So let's get right into it. We're going to make a chess game from scratch. And there's a little joke in here that you'll see in the not too distant future. We're going to add the Socketio framework to actually make it multiplayer. And you'll see some of the benefits of what Socketio is and why we might want to use it. And then we're actually going to publish it online so we can actually make it actually multiplayer. And at the end, we'll all be able to play the game that we make here in the room in the time that we have. So what is Socketio? Socketio, let's just go check out the website. They have a really cool demo. The hello world of Socketio is a chat app. So basically, we could all join a chat room and just talk to each other. And essentially, I think it's like 7 lines of code, which is like, in terms of the actual communication piece, which is amazing. But as I've been tweeting to the Socketio Twitter handler, their demo is just broken on their website. And I didn't have the energy of like deploying the demo on my desktop. So I'm not going to show you that. I'll just show you the chess game later. But Socketio is awesome. If you've been doing web development and you've been using, most cases we use REST. You create that connection to that server. You post or get data from that server. Each connection is a new connection, and there's some amount of overhead with actually initiating that connection. You've got the latency of actually getting to that server, and then the cost of actually creating it and closing it each time, right? And in most cases, when you're navigating, between documents or getting, data from a server that that you don't need to update regularly, REST is actually beautiful. It works great. But in something like a chess game, when really microseconds or milliseconds could matter in the experience that you're delivering, then having that persistent connection, having a connection that can stay up to date in real time is hugely advantageous. So Socketio essentially wraps WebSockets, which is essentially a persistent TCP connection. So it creates that connection, it keeps it open, and then you have that two-way connection, and you can essentially just like flow data and messages back and forth across that connection from the server to the client. And I'll show you some examples of how to actually do that. Socketio has anyone done SignalR on C#? Okay, a couple of you. Socketio is a JavaScript on the server implementation like SignalR. So like Socketio is to JavaScript, is SignalR is to C#. So even though you've got your Socketio server running in Node.js, the clients could really be in any language. So I'm going to show you a web client for Socketio today. It's just a Node.js server with a web front end. But you could have a Node.js server with a Windows or an iOS or a web or an Android front end. Like the actual clients can be multiple environments, which actually makes it really desirable if you just want to like have a real-time communication across all different kinds of clients. So one thing that's important to understand about, one thing that's unique and interesting about Socketio, let me pull back up my slides here, is it really has the same calling pattern between the servers and the clients. And you'll see some examples of that. Let me just go right to that slide here. If you want to send a message, or like really send a message to all of the connected clients from the server, you can use this io.emit function. So the io is the Socketio object, and you can just like say, hey, send hello world or send hi to every connected client. And then there's socket.broadcast. So a socket is essentially one instance of a client that's connected to it. You can actually say, hey, socket.broadcast, if I've got one socket, let's send a message to everyone but this one client that I've got. And then there's socket.emit, which is just send a message to that one client that you've got a handle to. And then socket.on is really it's a callback. So you pass your function into that you want to handle messages. So you're listening for the hello world or move chess object. And this will all become a lot more obvious in the actual example. But what's interesting about this calling pattern is if you're doing JavaScript on the client and JavaScript on the server with Node.js, you can it's like the same code, essentially. It's not exactly the same code, but it's essentially the same code. Even if you're doing like a Swift client, it's still the same verb names, which makes it really nice. You just have to think about actually the same concepts, and then you just have to make them work across the different clients and servers. Another thing that took me a while to grok, because the calling pattern is so consistent between Socketio, between a front end and back end JavaScript implementation, it was like, well, how is this even distributed? And when you're actually looking at your code, you may have two code files. You have like your app.js, which is like your server, or your index.js for your server, and then you have your index.js for your client, which is actually that connection. It's like, oh, I just have two things. I've got my server and my client. But actually, you have one server, right, that's loading in the Socketio node module, and then you have n clients. It's really, really good to remember, like, it's not like, even though you may have written one index.js for your client-side JavaScript, every tab in your browser is a new client, right? Or every iOS app, every iOS phone that's connecting to that server is a unique client. So when you're thinking about writing code and kind of like how many clients do I have connected and stuff like that, that's an important concept to kind of wrap your head around because the server is going to deal with all of those clients together. So I think it's a little bit more straightforward. Let's just look at some code. Let's look at this example. Let's see if we can use Socketio in a real-world example to make chess a little bit more satisfying when I beat my brother-in-law. So let's get right to it. Oh yeah, good news. Actually, let me just keep this up here. I see a few laptops out here. I just gave this same talk at that conference in Wisconsin, and it was 30 minutes, so it was like a kind of a mad rush. But we've got a little bit more time with this talk. We've got 50 minutes. So I'll go at a more reasonable pace. So all of the steps for what I'm walking through here, I actually published on GitHub as a kind of follow along lab. So if you like to code as you watch, or you want to code ahead, or if you miss something and you want to look at it, you can just check it out and see kind of what we're doing here. So all the code and also the steps for what we're doing are I put on GitHub for people to follow along. Okay, let's get right to it. So we want to make a chess game, and we're gonna start in Node. I'm just gonna go over to my console over here, and I'm gonna make a new folder here called My Chess because it's my chess game. And then many of you raised your hand and said that you're Node developers. I'm kind of trying to stay away from boilerplate code and stuff just to keep things simple for everyone. So we're just going to do an npm init, and we're going to create a new Node project here. Called it My Chess. That's great. The default entry point here is index.js. I'm going to use app.js. So we're going to be publishing this to a cloud provider. In our case that we're publishing, they like it to be called app.js. And then I don't have a Git repository, or I don't need any of that stuff right now. So great. And let's go ahead and open up this folder that we just created here. I'm using Visual Studio Code, so I'll make this nice and big. And then here's our package. All that we've created so far is this package.json. It's got a name. It's got an entry point, which is app.js, and nothing else. So first thing I'm going to do is just make a basic web server to serve up my static HTML content. And even though I'm not using boilerplate, I will be using snippets, but don't worry, I'll walk through all the code that I drop here. And let me know, I'm not really looking at this as much as I need to, so if something is clipped or something on the projector, just let me know. So if you haven't built an Express site in Node.js before, I'll walk through this really quickly. I'm using this Express module, npm module, which is just great for serving up static HTML pages. I'm using the static for the specific folder that's going to be serving up my HTML and JavaScript. I've got a port that I've defined. This may not be familiar to you if you've only done kind of local stuff, but here I'm actually using the environment variable for the port because if I'm hosting it on a server, I may not have actually control over what port the server is actually running on. So, and I just OR that with port 3000 because that's what I'm going to use locally. And then I'm going to serve up a specific folder with my default.html, and then I just log it out. So let's go ahead and make that folder that will just have our basic web server web content in it. So default.html, default or public, and then we'll put a default.html inside there. Okay, and then hello Midwest.js. Okay, so we've made a basic Express server. We've got some static HTML content that we'll soon replace with a chess game. Since we're using Express, we need to actually go and get that Node module. So I'm just going to do an npm install Express, which will go and download that from npm. And I'm going to do a --save, which will actually declare that dependency in my package JSON. So it's kind of like 2-in-1 if you haven't done that stuff before. If I was just coding this locally for the demo, I actually wouldn't need to do --save, right? Because my project would just have those node modules copied into it. But actually, at the end of this, we're going to deploy this project to the cloud, right? To a place that's actually going to host this. And we don't want to deploy all of our node modules. So it becomes essential to declare in our package JSON which dependencies we're going to use. So sometimes that's kind of like an extra step, but no, it's actually required in the case where we're going to host it. OK, so I've got my code. I've got my default HTML. Let's go ahead and run this. Visual Studio Code is like an Atom debugger, and it also has a Node.js runtime support baked into it. I'm not going to edit this workspace file that it creates for me. Like, you can declare environment variables and stuff, but I'm not going to do that here. So let's just go ahead and run this, and let's find a tab to try this out. Yay, web server, we created a web server. It's like, so when we said intro track, we're starting from scratch. So sometimes it's when I go to talks and it's like, how do we get from this to like the end thing? And there's like 30 steps that we skipped along the way. So I thought let's just start with hello world on the Node Express server side. So let's actually make a chess game, right? Before we can make a multiplayer Socketio thing, let's actually make a chess game. So somebody out there, if you're going to, let's say you wanted to make a chess game, what's the first thing you would go and try to figure out? Like, what's the first thing you would try to do? Find a board, right? Because, yeah, that kind of sucks to like have to code up in all of those grids and layouts and stuff like that. Maybe you'll go find some chess pieces, like open source, like open art for the actual chess pieces. What else might you want to go do?
See if somebody else already built it.
Yeah. Does anyone have like a chess control? And actually I started the other way, because I actually like to do the UI part. I'm like, okay, I'll build a UI board, and let's see if somebody did the chess logic. Because when I started implementing it, I was like, oh, what about like en passant, and what about castling and capturing moves? All the logic part, like that's kind of a lot of code, and it's kind of complicated. And I was like, well, let me just do some like GitHub sleuthing. And turns out, hilariously, let's go back to our code here. It turns out, let's update our default.html, and let's look at kind of this basic HTML code that we dropped in. It's got some style sheets, but it turns out there's two libraries that become incredibly helpful for us. One is called chess.js, which is a chess logic library, all client-side JavaScript, and it has a game object for every game that you create that maintains the state of like, hey, where are the pieces, right? And then turns out, and then I was like, okay, that's amazing. Now I have to build a UI. And then I found chessboard.js, which is the UI. And like, since chess has been around for thousands of years or whatever, I don't know, not thousands of years, but it's been around for so long that like, there's a standard notation for chess. It's called fen, for the board and for every move. And so actually communicating between the chessboard UI library and the chess logic library is just a matter of using that fen state, which is like hilarious. So like, actually, if you came here like because you wanted to learn the like nuances of building a chess game, I lied. We're not going to do that. This is like, it's Midwest JS. Like, you do the JavaScript thing, you pull in the libraries, and then the chess part is done. So if you actually look at the HTML here, I've got chess.js, chessboard.js, which is the UI, and then the chessboard UI actually has a dependency on jQuery. I don't usually use jQuery, but chessboard pulls it in. And then we've got our default.js, which is where all of our logic's going to be. The only other thing that we've got in here is a div, which is our game board. So that's actually where the UI is going to get dropped into. So let's go ahead and, we've got these libraries. We didn't actually add them to the project yet. So I'm going to just go to this folder and drag and drop those libraries in. So, and this lab resources folder is in that GitHub. So if you're following along and you just clone the zip, then you can just copy this image folder and the lib folder into the public part of the project that we just created. Okay. So there's no magic here. Everything that's in image is just the chess pieces. And if you've seen these chess pieces before, it's because they're the ones from Wikipedia. So they're like, they're Creative Commons and awesome. So every online chess game uses these. If I had time, I'd be like, oh, let's make a Midwest.js chess theme and make my own pieces. But I haven't gotten around to make my own custom chess game yet. And then in the lib folder, we've got the chess library, the chessboard styles and library, jQuery, and then later we're going to pull in the Socketio client library. So we're not using that yet, but we're going to pull that in. So that's all that we've copied in so far. Okay, so we've got our basic HTML file. Let's add some styles so we actually can center it. So I'm using Flexbox, which is amazing. And now more browsers are implementing grid too, which I think is awesome. I love grid. I don't like messing around with absolute positioning stuff. But I just center the chessboard, and then I give it a width. If you don't, the way this the chessboard control works, if you don't give it a width, then it just explodes everywhere. So it needs to have some width to start with. And then let's actually add the logic here. So default.js. And I'll walk through this a lot more slowly. Is it big enough on the screen? Can you guys see this at all? Okay, good. I'll even notch it up one more just to go into full grandpa mode on the font here. Okay, so there's two objects that we're dealing with, right? There's the board, which is the UI object, and then there's the game, which is the logic, right? And those are will be instantiated to be objects of those two libraries that we pulled in. When the window loads, I just call this a init game function. And this config object that we're building out is just settings for the UI. So we say draggable. Sorry, I have a habit where I click everything. So we say draggable, which says, hey, it's allowed for someone to take a piece and drag it with their mouse or with a touchscreen. So that's the first option we set to declare. Position, so this is actually a fen format. So we can say, hey, start the board in this current state. So start the chessboard with the pieces in these spots. And then, but we just gave it start, because it's okay, just start it in the initial chess environment. And then on drop is the function to call when you actually let go of a chess piece. There's some other nice callbacks that you can implement, like on drag start or on drag move. There's some other interesting ones. Like if I wanted to go really hardcore with this chess game, and actually I want to do this at some point, when a player grabs a piece, the other person that's seeing it should be able to see you drag it around, right? That's really real time, right? I didn't do that yet, but in this case, we're just doing handle move. So when you drop it, let's actually implement this. And then we've got the board object, which is the UI, and it's just declared to use that div that we used in default.html. And then the game is the logic. And this function that we implemented here is called handle move. And what that does, source is where it's coming from, and target is where it's going to. So the UI gives this handle move function the source and the target location. And then since it's that same format that I said, you just call the logic, this game object, with the source and the target, right? So that just tells the logic, hey, this is what the current state of the world is. And then that allows us to actually validate moves. That's really all that, because the board is dumb, right? The board is just UI. It lets us put pieces anywhere. The logic is actually what validates and says, hey, did a piece get captured? What's the status of what's going on, right? And you can see here that it says move equals null. And so basically, this game.move function will return null if it's an invalid move, right? So if you try to move a pawn 5 pieces forward, that's an invalid move. So it will return null. And then so this, by returning snapback, that will essentially not let the piece drop where the player tried to drop it, right? So again, we built, at this point, we built a chess game. What I've showed you is not actually how to build a chess game, but how to make use of these two particular libraries. But in many of your cases, let's be honest, you're not going to do the other part. You're going to use a library. What's cool about this is you may, even with the logic, you could build your own front end using WebGL, or re-implement, some other, you could do like an iOS sort of implementation, but the actual concepts remain the same. So let's go ahead and see if our chess game works. So I'm gonna just click run here. And we'll go back to localhost. Let me close these folders. We don't need these. I don't want to do that. I want a new browser right here. There we go. OK, chess game. We got a chess game. We've got all of our pawns. This is just the start position. And I can grab a pawn, move it one forward. If I try to move a second time, right, it won't let me, right, because that's an invalid move according to chess.js. But if I go ahead and move a black piece here, it will let me do it, right? So we've got a chess game. Yay, we're done. Yeah. OK, so yeah, this is just the beginning part of the talk. Let's actually get into the meat where we actually make it multiplayer, right? That's really the point of this talk. So what we're going to do is we're going to use Socketio. So let me go ahead and let's go ahead and add that. So I'm going to start with my app.js here. And just like how we've required Express, we're going to you pull in a Socketio dependency here. So we just do IO, which is going to be our Socketio object, requires the Socketio node module, right? And you can see it actually attaches to our HTTP client, for HTTP server for what we created for our Express server. So first we initiate that, and then we're going to do kind of a hello world of Socketio. So basically, if let's actually send our first message from a client to the server. So in the server here, we're listening to connection. So remember I talked about that calling pattern, io.on. So anytime there's any message, io.on is essentially going to be called if it's the message that socket.on gets called for that message. So in this case, there's some common messages that get sent. So connection is one. Disconnect is another one. There's like there's a lot of ones that you can look at the documentation. But connection is a good starting point because that's a good way to kind of get a handle for each one of the connections that connects to your server. So we're just going to log out, hey, somebody connected. And we could log out the ID for that connection or how many clients we have connected. In this case, we're just going to log out new connection. And then we're going to start listening for a new message that, in this case, we creatively named message that will get called if somebody emits it. And then in the callback, we just log out what that message is. Got a message from client, message, right? So if you've done Socketio before, this is probably relatively basic. But if this is the first time you're seeing it, there's really not a lot more in terms of using this besides what you're seeing here from the server side in terms of doing something straightforward. So on the server, we're listening for connections. And then when we get a connection, we're listening for a message called message from each of those clients. So let's go ahead and send a message up to the server from our client here. So what we're going to start off, just as a hello world for this, what we're going to do is we're going to, anytime that you click anywhere in the body, we'll just send the message, right? So, so here, again, if you're getting kind of lost in the JS files, we've got app.js, which is our server, our Node.js server. We've got default.js, which is the client that will be copied to every tab that's instantiating here. And then as soon as I say socket equals IO, this client is going to try to initiate a connection to its server, right? And a lot of times when you do socket IO here, you can actually pass in the URL for your server. In this case, since my Express server is actually hosting up my static HTML, socket IO has some handy stuff that will go find its server, right? And it was possible since I passed in that HTTP server in my socket IO server implementation. So here is where I'm actually initiating the connection to the server. And then I just got a window on click socket.emit message, right? That's the message that I'm listening to on the server. And I'm just going to emit hello world. Why don't we emit hello Midwest JS, right? So we've got our server that's listening for a message. We've got our client that emits a message when you click anywhere on the window. We just need to make sure we've got these libraries installed and good to go. First of all, I'm going to install I'm going to add the client-side library. So just in all of my default.html client-side library declarations here, I'm going to add socket.io as a client-side library. If you're following along in the code, it actually matters where you put this. Like if you put this after default.js, then it won't be loaded at the right time. So it's important for it to be here. So I've got my client-side library plugged in. And then remember, we're using this socket.io node module. So just like what we did for Express, we need to go install that as well. So let's go do it. npm install socket.io --save. And remember, --save will actually add it to the package.json. So when we go and deploy this to somebody else that's going to go get our node modules for us, it'll go get this. I see some nodding heads. Are people following along a little bit? Okay. And then if you have any questions or if you missed a step, this is the beginner track. So if I have no problem going back and talking about a step that if we went too fast over. So, okay, at this point, we've got, we should have socket.io working on the server, and we should have socket.io working in the client and actually emitting that message. So let's actually go try it out. Go to localhost here. And then so if I click anywhere in the window here, it should emit that hello Midwest JS message. So I click here, and I go over to my debug console here, and you see new connection, and you also see got message from client hello Midwest JS, right? So we've got that basic connection created. I don't have this showing on the same window, but if I click, every time I click, that message gets to the server. And it's not like REST where it's like, okay, connect, and then like, oh, here's all the payload with the headers and blah, blah. No, it's just like, no, it just sends it. It's like very lightweight. That's what's kind of fun about this is there's not a lot of other garbage. Just sent the messages over there. Every time that I create a new connection, so let me go back to this tab. If I go and do another tab for localhost, oh, they actually moved the chess piece there. You can see I've got a new connection that created too. So you can actually, what was that talk on Thursday? There was a talk yesterday when somebody was saying that like a standard EC2 instance can do something like 500,000 concurrent connections. Did you guys see that socket.io talk? It can handle quite a few connections without too much CPU load. So 500,000 idle connections, I think is what he said. So we can have all kinds of connections, all kinds of clients, all kinds of tabs, all connecting to one server, all sending messages, and that node server is kind of the traffic cop that's actually determining what to do with it. So that's cool. In this case, I think we could even set a breakpoint and see what's going on there, but we'll look at that later if we run into issues. Again, just another plug for Visual Studio Code. Like no debugging if you're just kind of doing some basic code. Like you don't, sometimes just console logging it out is fine. But like if you've got messages from end clients coming in, it can be a little dicey, like to actually just console log it, because the ordering of everything can be problematic. So in this case, actually having a real debugger where you can break in and inspect, what's coming in over the wire is handy. So let's actually make this game multiplayer, right? Does that sound good? So let's start with our client. What we're going to do here, we can delete this window.onClick thing. What should we do, right? Like, instead of sending hello world, what should we send up to the server when you make a move?
Sure,
The move, yeah. So let's do it, right? And what I'm going to do here is basically, if the move is not null, right, then send it to the server. If the move is null, like if somebody tries to do an invalid move, then don't send it to the server to notify somebody else, because they didn't try it. They didn't do something good. But if the move is not null, then let's do a socket.broadcast.emit a message called move. And this is what's one of my favorite parts about Socketio, which actually can be dangerous, is you don't even have to serialize. I don't have to serialize the move into text, or serialize the JSON into text and then deserialize it on the server. It's one library that's running. It's one suite of code that's running across the server and the client. So you can just send whole objects up there. So I actually just send the entire object as it came from the game state object up to the server. Yeah.
I thought the calls were going to be socket.emit or socket.broadcast.
Yeah, sorry. When I missed that in my note here. So socket.broadcast kind of just changes the window to what you're pointing to. You still call emit to actually, the verb is still to emit. So socket.broadcast, just a reminder here, if I were to say socket.emit, then it would actually, you're right. I'm only one client, so I don't need to broadcast anything. I am the client. Yeah, exactly. Yeah, exactly. So good catch. Yeah. So since I'm on the client, I just have to emit up to my server what my move is and actually send it up. Yeah. So a reminder: socket.broadcast sends it to everyone except the socket that you're pointing at. So if you were to, that's relevant from the server perspective, because when we go and send, and let's actually get right to the server. So here we emit the move up to the server. Let's go and handle this from the server. So instead of actually listening for message, let's listen to move. So got a snippet here. So here it's listening for move. And so it's going to, anytime it gets a message called move, it's going to take that message, or in this case, it's going to be that entire move object that it got from the game, and it's going to broadcast back to everyone. And that's why when I started with that diagram, it can get a little bit confusing, because you're writing JavaScript on the server and JavaScript on the client. So you're like, oh, where am I writing code right now? So in this case, it's relevant to say socket.broadcast, because I don't want to send the move back to the person who just sent it to me, right? I want to send it to all the other clients besides the one that I send it to me. Does that make sense? It's kind of confusing, because if I were to say socket.emit on the one that gave it to me, then it would be one-player chess, right? Like, hey, you gave me a move, give a move to the server, and then give the move right back to the same person, and the other person is still waiting for that move, right? If I were to say io.emit, which is not any socket in general, just give the message, give the move to everyone. Then I'll give a move, and then the person who just did a move is gonna try to reconcile a move that they did, which will fail every time, right? So really, what I need to do is send, when I make a move, send that move to everyone besides the person who just initiated it, and that's what socket.broadcast does. So in this case, the server isn't really doing anything intelligent. Like, I send the move up to the server, socket.emit, here's my move, and the server says, okay, let me just give that to everybody else besides you, right? So socket.broadcast.emit, And then now what do we need to do?
Respond to it in the client.
Yes, exactly. So let's go to default.js, go back to the client, and then socket client move. So then on the client, I listen for move. Again, see, it's socket.on on the server, it's socket.on on the client, and then I just do game.move. So that's actually trying to reconcile the move that I got from the server with the client-side version of the game that I've got. If it's a valid move, then initiate it. And then what I actually do here is I just update the board to match the game state, right? And that way, like, I don't have to worry about playing back all the moves directly. I just make the game right. And there's a lot of different ways you could do this. I could maintain the game state in the server to like prevent cheating a little bit. Like, I guess there's a way you could kind of cheat this a little bit. But this was the most direct, most straightforward way to do this. So at this point, we should have multiplayer chess, right? We are sending moves up to the server. We're broadcasting them out to all the clients that are listening for moves, and we're reconciling them locally on the client, right? So let's try it. OK. So I've got 2 windows here because we need more than one client. Close 3000. OK. And then I'm going to go ahead and make this move here. And it updates in the other tab. Ooh. Right? And then I can go ahead and make another move, and make another move, and make another move all day, right? And this is fairly unintelligent at this point, right? So if I go ahead and open another tab, and we'll be able to play with this later when we post this online. If I open up another tab, this one starts off as being out of sync because it's just, remember, when we start the JavaScript client, it actually just initializes it. But I'm pretty sure yeah, like, so we kind of gotten into we kind of got into a weird state here. So then as soon as this guy, see, now it's out of state, right? Like, that's actually where you actually need to have a server game state. And that's not necessarily how chess works. You don't necessarily, unless we were building Twitch builds chess, you don't necessarily have like one player versus the room and everyone gets to kind of make a move. But so, obviously there's some challenges, but for the, as long as you initiate the board at the same time, then, you'll be able to have, the multiplayer chess working. Does anything stand out to anyone who's watching? Anything that's kind of neat about this?
One person can make the moves for both sides.
Yeah. Like, I don't actually need to, switch boards. But because of how we've built the Socketio messaging, the other client listens. They're hearing all that traffic, right? There's and all of the code for when we finish this talk, I'll show you guys a demo of kind of a more complete implementation that handles some more, some interesting states. But yeah, all of the code is just broadcasting to all the clients. Yeah.
So you asked like what we thought was interesting. This is in the context of a game, but like at a company, we use SignalR.
Yeah.
Specifically for .NET, but for whatever you use Socketio.
Mhm.
Like if someone is working on like a support ticket, or they're working or like viewing a page and you have other team members, you can use like WebSockets to do like, who else is viewing this? Oh,
Exactly.
Can I have live chat with them? You can do like notifications when like a user is editing something.
Exactly.
You want to lock it or you want to collaborate.
Yep.
It's really awesome.
So, that's what I was kind of getting at. Like, what you may notice, which is not traditional for many web and HTML demos, is like, this is fucking fast, right? Like, and we're on the same PC here, but even when, besides the latency that you'll have on the first connection, it's real time. It's as real time as you can get, given the limits of your connection, once you actually have that connection created. And it changes the game on the sort of experiences you can create. I think that's what excites me about this. I'm kind of, at heart, even though I like to write code, like at heart I'm kind of a user experience person. So I like to enable more interactive, more engaging, more live experiences And anyone with an iPhone or uses Facebook or Skype chat, when you actually see someone is typing, that kind of changes the game of the conversation. You're kind of like, oh, you started typing, then you stopped typing. Why'd you stop typing? I know you're there. It's like, that's different. I mean, that's a different user experience. It's more like if I were to start talking to you and be like, yeah, like there's a lot more nuance in, these real-time connections that you can convey in your user experiences than you can in a traditional, REST-based, turn-based user experience. So let's actually go and deploy this, and I'll show you kind of the steps that I took to actually go and host this online, and then we can all play together in the room, and we'll kind of do that whole Twitch plays chess thing. And where we're going to be deploying this, so I work at Microsoft, just in case you guys were curious, but we're going to deploy this to Azure, which is Microsoft's cloud. It would be just as easy for us to deploy this to, I thought I had a tab open here, but I guess I didn't. It would be just as easy for us to publish this to Heroku or to AWS, like an Elastic Beanstalk server or something like that. In this case, we're going to publish it to an Azure app service, which is essentially like an Elastic Beanstalk. So let's go ahead and I'm just going to add a website instance here. And let's call this My Chess if it's available. No, let's call it Midwest Chess. Okay, it's available. And then I'm going to just add this to an existing resource group. A resource group is just kind of like a collection of assets that you post to the cloud. If you're not doing any kind of AWS or Azure stuff, you realize after a while that like you've got a lot of stuff just floating all over the place, and when you want to delete it, it's like a lot of like deleting or scripting to go delete it. So by putting it all in one resource group, I can just delete the resource group and everything gets deleted with it. So let's go ahead and create this. And then we have a number of options for how we can go deploy code to a server like this. We could FTP it up there, but that's kind of old school. There's some other crazy deployment options. Like you can put it in a Dropbox and then have Azure just monitor that Dropbox and continuously deploy it. So if you're like really a hacker and you don't want to use source control, but you want continuous integration, you can just like have it monitor Dropbox. In this case, like we're developers here, like we can use some Git, right? So what I'm going to actually do is let's actually initialize a Git repo for this project, and then we'll deploy it using Git. I use Visual Studio Code, as I mentioned before. It's got a nice way to initialize a Git repository right from in VS Code. Most of the files that are deploying here are just the node modules. So let's go ahead and actually add a gitignore file, and let's put it in the right place. And we're going to ignore node modules, and we can ignore this VS Code folder. The VS Code folder just has like the project settings for VS Code, like what the local environment variables are and stuff. And then when I save this, it's a lot more reasonable set of things that we want to deploy here. So we've got app.js, package.json, our client-side JavaScript and HTML and CSS, the chess pieces, those libraries, the JavaScript client-side libraries, and then Socketio client-side library. I suppose I could have pulled those in from a CDN. I didn't. Initial chess commit, right? So I committed it just to my local Git repository. So I've got two options here when I'm deploying to the cloud. I could add a GitHub remote. So I could actually publish this to GitHub. And then I'll show you, Azure can actually, let me go to this website. What do we call it, My Chess or Midwest JS Chess? Midwest Chess, there it is. So it's got some information, the FTP credentials and stuff like that. But the thing that we want to do, resource group. No, I don't want to restart it. It's like this page isn't loading. Sorry, I'm just going to refresh this. So Midwest Chess, it gives me all kinds of settings. Settings. Maybe I have to click this settings thing. Okay, weird. So there's all kinds of settings over here for like setting environment variables and like how beefy you want the server to be. Because this isn't a virtual machine. It's kind of like a logical server or PaaS. Like I said, like an elastic beanstalk. So you can have it auto scale based on CPU usage or time of day or something like that. But let's actually look at deployment. So when I choose deployment source, I can choose, like I said, I could deploy from OneDrive or from a Bitbucket or from a Dropbox or from GitHub. What's nice about the GitHub deploy here is you can just OAuth in, so you just log into your GitHub, and then you can browse through all of your repos and just deploy a direct repo. So like if you guys want to play around with this, you could just fork my repo and then just deploy it directly, which is kind of nice. In this case, we're just going to say deploy local Git repository. And then I'm just going to click OK. And what this will do is it's kind of funny. The terminology is kind of funny. But what it does is it creates a Git remote on that server. So instead of adding GitHub as the Git remote, I can just add this server as the Git remote. So, and I think it's up here in properties. I think I can get the Git remote URL. Yeah, here's the Git URL. And so I can just go back to my thing here, and I can git remote add master. Paste. OK, so we added the master. We added the remote, which is that Azure site. And then, interestingly enough, if we want to actually deploy this to that cloud and deploy any changes going forward, we just have to do a publish or a git push. So any additional changes, any additional git pushes, now I need to log in. I always forget which credential it asked me for. I should have saved that before I did the demo. So any additional changes that I commit to this Git repo and sync up to the remote will actually get published to Azure. So we can actually look at the deployment. Let's look at this, the deployment source here. And it shows, see how it says like it's committing? So anytime I do a commit from now on, it will actually show it bubbling up here. The first commit actually takes a little bit longer, because remember, we didn't deploy our node modules. So what Kudu, which is like was what Azure's app hosting thing is going to do, is it inspects the project. It's looking for app.js. This doesn't have to be a node server. I could have deployed a Python server or a C# ASP.NET server, or I could have just put static HTML up there. And the Kudu service will determine what kind of project it is magically. You can give it hints if you want to, but in many cases you don't have to. It'll just deploy what's there. And then once it actually deploys the code from your Git repo, it's going to look for that package JSON and actually go get all those libraries from npm. So you don't have to actually, you don't have to actually maintain those, and it's respecting the versions that you say there. So if you say, oh, greater than version this, then it will deploy those versions as well. How are we doing on time? Do you guys know when this is supposed to end? 10 minutes. Oh, perfect. 8 minutes. You're supposed to be heckling me more.
I should be. It's so good.
The next session starts.
Okay, so let's wrap up here. So midwestchess.azurewebsites.net. It said it was still deploying it here. While we're waiting for this to deploy, everyone go to aka.ms/realchess. And this is a more complete version of the project. And the login here is fake. Like, you just give yourself a name. So I'm going to give myself David W. And then when somebody logs in, so there's Sam. So Sam, or Safia. So Safia, you and I are playing chess together right now.
I'm terrible at this game.
So I'm first, I guess. So make a move. There you go. So now we're actually playing chess. And this is the same code. The only thing I did is I wrapped up a really kind of crappy login thing. So you actually have users a way to join. The way you join a game is you just click on another user. And what you guys should actually do is actually play chess. So if you're not doing it right now, actually start engaging and playing chess with people. I added a little bit more code here that actually shows all of the games as they happen in real time. So, I mean, and you know, this is a gimmick. You know, there's not really a practical purpose for this dashboard besides just feeling like the master of the chess room. No, but going back to where I started with like being in a chess hall, like this is kind of that same feeling, right? It actually feels interactive. Like you can see the excitement, like what's going on here? These guys are trying to, you know, play something. Oh, he just made a move. And you can tell that it's actually, you know, real time. It's actually fully interactive, really with just a few lines of Socketio to send the messages back and forth. So let's see if this deployed here. It looks like it's taking a little bit longer. I don't know if it, oh, I wonder if I typed in the wrong credentials. I may have typed in the wrong credentials for my Git repo. And then, so yeah, and then it commits, and we're off and away. So just in closing, again, if you want to walk through these steps on your own, just go to aka.ms/chesshol. And the demo that you guys are playing with now is real chess. And then check out my blog. I've got a write-up that's kind of like a blog version walkthrough of what we did. And I do all kinds of other projects. Like I said, I'm a hacker, so I made an iOS app to control my garage door. Hands-on lab that we were talking about is up on my blog as well, or is on GitHub. And then feel free to shoot me an email. I would love it if someone in this room were to fork the project and kind of like actually make it more interesting and more complete, or at least work on it with me, because that's just the cool way to go. And I, you know, enjoy the conference, and I really appreciate you guys taking the time. Thanks.